So in this video, I'm going to address the specific questions from the screenshot you gave me, as well as kind of talk a little bit in generalities about functions, composite functions, and how we figure them. I agree with you, you're right. These are a little bit strange. These are not typical questions in my book, but let's go ahead and take a look. Now, this is not a composite function question. I just want to preface this by saying that the chapter where we learn composite functions, there's a lot of work, precursor work to doing the actual composite functions. We study, of course, the definition of a function, what kind of an equation constitutes a function. We look at the difference quotient and do those. We look at the basic, how do you evaluate a function at a value, which I'm sure you know how to do. So like f of 2, everywhere there's an x, you plug in a 2 and you evaluate. And then again, the difference quotient. What we look at next is we look at what are called piecewise functions. We look at intervals of increasing and decreasing. These are piecewise functions. They kind of don't have anything to do with composite functions. We look at even and odd functions. We do a very quick review of y equal mx plus b stuff that's really in intermediate algebra. Then we learn about the transformation of functions. That means taking a function and then moving it using transformations, what are outside vertical shifts, inside shifts, horizontal shifts, and those kinds of things. We also look at reflections across the x or the y axis. And again, these are all transformations. And then we get into combining functions. And there are basically four basic operations: add, subtract, multiply, and divide, where you are combining functions. Now, what's interesting is when you combine those functions, in order to get the new function, like if I take f of x plus g of x, I now have a new function, perhaps h of x. In order to get the domain, you take the domain of f of x, intersect the domain of g of x, and that's going to be the domain of your new function. And the only one we really have to watch out for is division, because division by 0 is not allowed, and so you can never ever divide by 0. So you have to, when you're doing f of x divided by g of x, you have to have this disclaimer. But basically it's the same domain, you just have to clarify. And then we actually get into we do a couple of examples of adding and subtracting and multiplying and dividing. And then we finally take a look at the composite functions. And the composite function takes the domain of the first one and uses it as the range of the second one. And basically when you're doing a composite function, is you're taking, instead of doing like f of 2 and everywhere there's an x, you're going to replace it with a 2 and evaluate it this way. You're actually taking f composite g, or in other words, f of g of x. Instead of plugging in a value like here, we're plugging in an entire function. And so we're evaluating a function with another function, and that's the composite function. Now to these questions. This is not a composite function. I'm not sure. It's just because the screenshot had this one in it. That we'll take a look at this one. It really helps to know the transformations for this, what x squared minus 9 actually looks like. And this is a transformation where you take y equals x squared, where you've got the vertex at the origin, but you're moving it down 9 units. So if I come over here and clear this out and take a look at x squared minus 9. And just in general, look at his graph. You can kind of see from negative 3 to 3 where this guy kind of sits on this x-axis. So it's saying, given f of x equals x squared minus 9, on which interval will the value of f of x be less than 0? So again, having the graph in front of us will kind of help us decide where this happens. So where, and this is another thing to remember too, as we look at this, is understand that f of x is what's going on the y-axis. I don't know why I can't get this lined up. Holy cow, if it's not straight, I'm absolutely lost. But an ordered pair is usually x comma y. But remember, y equal f of x. So we're replacing the y coordinate with f of x. So if they want to know where f of x is less than 0, we want to know where the y values, where the y values of all the ordered pairs, where those are less than 0. So this is the y-axis, is the vertical, the x-axis is the horizontal. So if I want to know where f of x is less than 0, it's going to be all of these values below the x-axis. So since I know my x-intercepts are at negative 3 to 3, and I need to know where it's less than 0, and notice in the problem it didn't have the bar underneath, we know immediately that this guy's out because we know it's not negative 9 to 9. This guy's out because it's not negative 9 to 9. But this guy is out because of the bars underneath here. It's not negative 3 equal. They want to know where f of x is less than 0. If I evaluate at f of negative 3, or if I evaluate at f of 3, I am going to get equals 0. But equals 0 is not less than 0. So that's why we would ax that one out, and that would be our answer. And I would strictly use transformations, and I would use this graph to tell me that. But this is, again, a precursor right leading into composite functions. Okay, so there's that one. Now, this one can be done two different ways. You could go ahead and composite these functions to figure out which one of these is true. If I were really taking this test though, and I had to pick one of these answers for these two guys right here, I don't think it would be worth my time to composite them, look at the domains and all that stuff. I would just simply be in, okay, here's f of x, this is g of x. What's f of 0 and what's g of 0? Well, g of 0, 0 over 4, that's going to equal 0. 2 to the 0 equals 1. And so I would say, is 1 less than 0? No, it's not. That guy's out. Then I would come down here and look at f of 1. f of 1, 2 to the first power is 2. G of 1 equal 1/4. 1 to the third power, so that's going to be 1/4. Does f of 1 equal g of 1? Absolutely not. And that's out. What about f of 6 and g of 6? Well, I don't know what 2 to the 6th power is, but I'm pretty sure it's 64. So this is going to be 64, and 6 to the 3rd power is going to be 216 divided by 4, which is 54. Is f of 6 less than g of 6? It is not. Now, 2 to the 4th power is 16, so f of 4 is 16. g of 4 is going to be 4 to the third power. 4 to the third power, which is 64 divided by 4, and that is 16. There's your guy right there. This is going to also be false. So as painful as it may be to just go through and evaluate each one of those, honestly, you can do those in your head, and I think for me that would be the simplest way. Again, there is another way to do this, but it is so much more complicated than just going through the list until you get a hit. I'm pretty sure that's going to be, because 2 squared is 4, and this is going to be 8 fourths is 2, so 4 is not less than 2, so you're done with that one. That one's not going to be true either. Okay, so that's how I would do that one. I just really wouldn't composite them and waste my time with that. This one is also, how I say it, pretty arbitrary and pretty stupid question. But obviously x can't be 0 because we can't have 1 over 0, so they make that clarification. And now they want to know where a is between 0 and b, which one of these statements is true. Again, these are not real values. A could be any real number. B could be any real number. We have absolutely no idea what they're talking about here, but I do know what 1 over x squared looks like. And again, that comes from the transformations that we do in the preceding chapters. So I do know what 1 over x squared looks like, and it looks something like this. So basically, this gets infinitely close to the x-axis. It's going to get infinitely close to the y-axis. And then again on quadrant 1, same thing. You're going to get infinitely close here, and you're going to get infinitely close here, but never cross that vertical asymptote and never cross this horizontal asymptote. So now we know what 1 over x squared looks like. But now we want to know, if we take this guy and plug in some value h of a, is it going to equal h of b? Well, they don't. They give me this statement that just tells me a is less than b. And we know 0 is less than a. So we know a is positive. In fact, we can take this whole, this is called a compound inequality, and we could break it up. We know that a is greater than 0. We also know that a is less than b. So this guy right here, this is out. If a is less than b, h of a is not going to equal h of b, because a is less than b. And if I evaluate that function, that's not going to be equal. So that's out, and that's going to be out as well. So if a is less than b, so here's what this is such a stupid question. So probably what I would do is I would choose a value for a and a value for b. Let's say, let's let a equal 2 and let's let b equal 4, and just, plug that in and say, all right, let's do h of 2 and let's look at h of 4. Now 2 is less than 4, so that would be a true statement. So 1 over 2 squared would equal 1/4, but 1 over 4 squared would equal 1 over 64. Well, 1/64 is smaller, so I would probably go with this one. H of a is going to be greater than h of b. Now, I didn't do a composite to figure that out. I'm just using the graph of what I know, and this information here was kind of key to everything. I don't need to do a composite in order to figure this out. I just need to know, okay, what does the graph look like? All right, how do I pick this guy apart? Okay, a has to be less than b. So if I evaluate h of a, obviously they're never going to be equal. I can't imagine there's going to be a value where that's going to be equal. This always going to be this way here. So I didn't do a single composite function in order to work these three problems, but it is definitely in that section or chapter 2 where we look at functions and we evaluate functions. We do look at the composite function, but we look more at the transformations, and I think that's really, to me, what these three problems are looking at, is more the transformations and evaluating instead of a composite. But I don't know if that's going to help or not, but there it is.